Imagine you're handed a math problem written in plain English, like prove that this sequence is arithmetic, and your job is to turn it into a formal proof a computer can verify. Sounds simple, right? But here's the catch. Most AI systems today can't do this. They need problems already written in rigid formal math language. That's where a new breakthrough called Mathesis comes in. For decades, AI researchers have been trying to teach machines to solve math problems. But there's a big hurdle. Real-world math problems aren't written in the strict, symbolic language computers love. They're in natural language, like the kind you'd see on a high school exam. So how do you bridge that gap? Mathesis tackles this by creating an end-to-end system. Think of it as a pipeline. First, it takes a natural language problem and automatically translates it into formal math language. Then it generates a step-by-step proof. The key innovation: a tool called Mathesis-Autoformalizer that uses reinforcement learning, basically, AI that learns from feedback, to get better at this translation. Here's where it gets cool. Traditional systems relied on humans to manually convert problems into formal language, which was time-consuming and error-prone. Mathesis, it's learning on its own. By analyzing thousands of examples, it figures out how to turn phrases like the sum of the first n terms into precise mathematical expressions. And it's not just guessing. It's getting feedback from a new evaluation tool called LeanScorer, which checks if the formalized problem makes sense. But how do we know it works? The researchers tested it on a tough benchmark called Gaokao-Formal, a set of 488 problems from China's National College entrance exam. Why this test? Because these problems are written in natural language, just like real-world math. The results? Mathesis-Autoformalizer outperformed existing systems by 22% on this test, and the full system achieved 64% accuracy on another benchmark. That's a big deal. What does this mean for the future? Imagine AI that can tackle complex math problems straight from a textbook or even a research paper. No human translation needed. This isn't just about solving equations. It's about making formal reasoning accessible to everyone. Whether you're a student, a teacher, or just a curious mind, tools like Mathesis are paving the way for a world where AI helps us explore math's deepest mysteries. So next time you see a math problem, remember, behind the scenes, AI is working hard to turn those words into proofs. And with projects like Mathesis, the future of mathematical reasoning just got a whole lot more exciting. Now, let's dive into the nitty-gritty of what makes this work so powerful. Take a simple math statement. Use ingredients a1 through n. In lean code, this becomes a function that grabs I plus 1 for I and 1 to n. At first glance, they seem similar, but here's the twist. The lean version is slightly more abstract. It's like a universal recipe that works for any number of ingredients, but in practice, we only need the first n. It's correct, but not a direct translation. We call this a minor inconsistency, small but worth noting. Now let's talk about comparisons. In math, if we say n bn, that's straightforward. Lean translates this as hab a n bn, which is perfectly matching. No issues there. But here's where things get tricky. When the math says st, lean uses s less or equal t. That's a major inconsistency. It's like swapping less than for less than or equal to, a tiny change that could flip the whole result. And here's the kicker. The researchers checked for hidden assumptions. No surprises there, everything s accounted for. So while some details are slightly off, the core idea holds. Why does this matter? Well, formalizing math in code isn't just about syntax, it's about precision. Even small mismatches can ripple through proofs. But hey, that's the beauty of this work. It's a puzzle and every detail counts. So what's the big takeaway? AI isn't just crunching numbers. It's learning to think like a mathematician, one formalization at a time. From generating multiple guesses to refining them with feedback, systems like Mathesis-Autoformalizer are bridging the gap between human intuition and machine precision. But here's the thing. Math is a language, and like any language, it's full of nuances. A single symbol, a slight shift in meaning, these can make or break a proof. That's why tools like Lean and the Mathesis family are so powerful. They force us to be exact, to leave no room for ambiguity. And let's not forget the bigger picture. This isn't just about solving problems faster. It's about building a future where AI helps us explore math's deepest mysteries, whether that's proving centuries-old conjectures or tackling brand-new challenges. So next time you see a math problem, think about the journey it takes to turn it into code. It's a dance between creativity and rigor, and AI is joining the dance. Thanks for watching. If you want to dive deeper into how this works, hit subscribe, and let me know in the comments what math problems you'd love to see AI tackle next.